Welcome to the next episode of TORGiren DevOps. Today we're going to start a new mini-series about procfs, and first in line are files descriptors. But before we start, I would like to invite you to the Atmosphere conference, which takes place in Warsaw at the 18th of the June. More information about event and a quiz where you can win a ticket will be at the end of this video. Okay, procfs is a special file system which help us to communicate with kernel Linux kernel. Okay, I won't describe all of these files now because it will be in another episode of this mini series. But what I can tell is that these files aren't physical files on any device. It's rather virtual files which help us communicate with kernel. For example, let's take a look for mem.info, where we have detailed information about memory in our system. Another useful file is load average, where we have our load average. But today we're going to talk about file descriptors. Let's start at the beginning. What junior sysadmin should know about file descriptors and how he could need them. Let's take a look about our bash process. Self fd like file descriptors. We can see that our bash process has 4 open file descriptors. Each file descriptor is represented by value, one integer value, which correspond to the open file by Linux kernel. But in user space, we use that numerical value to use a file we just opened. So there are 3 usually opened file descriptors: 0, 1, and 2. 0 file descriptor is usually a standard input, which is a keyboard if we don't specify another device. First file descriptor is usually standard output. So if we have any printf, echo, or anything that we print to the screen, it goes through first file descriptor, and second is standard error output. So if we have any errors, they will be written to the second file descriptor. How to manipulate these values from, for example, bash. Let's take a look about cat program we can cut a file. For example, etc. password. As you can see, the output of the file was written to the screen, because first file descriptor standard output is to our PTS, but we can tell bash to redirect our first descriptor, so standard output, to the file. For example, std.txt. Now, as you can see, nothing was written to the screen, because our standard output was redirected to the file. Let's check out what is in this file. This is our file, content of our file. Okay, what about standard error output? Let's try to cut a file non-exists. We got an error because there is no such file. And again, let's try to redirect the output to the file std.txt. We still can see the error, because errors are usually written to the standard error output, so they are written through second file description. So let's try to error. Now there isn't error on the screen, but it should be in our file. Okay, now let's try use both these functions in one command. So cut the password and non-exist. Okay, let's clear. We can see that there is our file and error. We have all of these things on the screen, and now we can redirect standard output to std and error output to error. No def, sorry. And as last, okay, here is a file, and this is very basic information about how to redirect streams. There are two very common redirects with stdout and stdr. First is to redirect to devnull, because there are sometimes situations when we don't want to catch error stream. There is also a situation when we want to redirect output to the file, to the devnull, because we want to take some action and don't bother with the output. And the third very useful thing is to redirect stdr stream to the stdout. How it works? Let's take a look about our example with one file that exists and one that not exists. We can see on the screen content of the file and our error. We can redirect our output to test, and we can see an error message because we only redirected the standard output, and we can redirect our STR and take a look. There is the error and the content, but we have to type path to our file 2 times. It's usually bad idea to duplicate code, so we can tell that we want standard output to be redirected to the file tmp test, and we want standard error to be pointed the same thing as the out. We can refer to the first file descriptor, and as you can see, there is also the same content. Okay, this is very basic usage with bash and file descriptors. When we need to know file descriptors, for example, let's take a look about Apache process which have this speed. We can go to prod speed of our HTTPD process and go to file descriptors. What we can see here, its standard input is dev null because this is daemon and it's don't write and read any input. First file descriptor is socket. We will talk about socket in a moment. Second, with errors is var log httpd error log. These are sockets and pipes, nothing important, and there is seventh file descriptor, which is var log httpd access log. When this information is useful, if we have some application and we don't know which files it use, any libraries, any log files, we always can find a bit of that process and check what files it open. For example, let's take a look about log httpd and make tail error log. Okay, there are some errors. It isn't important, but let's find our bit of our tail process and check its file descriptors. We can see that there is one file descriptor which point to our error log. So we have some process which open a file, and we can find out which files it use. What more? Okay, there is another useful folder named fd-info, and there we have information about our file descriptors, because our first three file descriptors are PTS, so it's nothing interesting. The fourth is iNotify, so it's quite advanced for this moment. So take a look about our normal open file. So take a look about what we have, what information we have in fd info about this file descriptor. We have pos, which mean position. This is a position in the file where we actually are. Because if we open file to read, we are default at the beginning. We can go to wherever we want by lseek, but if we open file, we are at the beginning. If we read some data from this file, our position is moved to the first not read byte. So if we open file, we are at the position 0. If we read 5 bytes, our position is at the 5, because 5 is the 6th byte. Yeah, okay. Flags. These flags, these are flags which were used to open the file. We will talk about them in few moments. And mount ID, which tell us on which device this file is placed. This is ID of the mount, and the list of mounts we can find in file mount info. And let's look for 61. There it is, and we can see that this is our root partition. Our file was varlog httpd, and check out that we have any partition for varlog. No, we don't have a separate partition for varlog, so our varlog is on our root partition. So this is true that this file is on mount 61 and its root partition. Okay, this is basics. Now take a look about another basics, but with some C programming. Okay, how these numbers are assigned. Let's write a simple application in C or maybe in Python. Okay, maybe Python will be simpler. Let's check out for this PID. Okay, we have to find this is our Python. We can see that it has 3 file descriptors, because this is usually opened by bash. And let's try open some file. For example, open tmp Python file for read write. Let's write. We can see that there is open file descriptor. When we open that file, how to find out its file number. Okay. From a Python shell we can find out which number it get. Yeah, but no, C will be better to show how it works. Let's write a simple application that open a file. Okay, we need to open a file, so let's check how to open a file in Linux. Okay, there is a function open, which is wrapper to the open syscall, and it get 2 or 3, but we will use this variant. It wants a path name to the file and flags to be used. So we need this includes. So our application. Yeah. Open a function return int. This is important because we tell the operating system that we want to open a file. Kernel open that file in kernel mode somewhere and return our process number, which is correlated with a file it opened. So in user space we operate through this integer, which is usually first three integer first three file descriptor number. Oh yeah. So integer fd open and make some file, for example c open that, and now we have to take some flags. Flags are described here. Oh, append, which is open a file to write and go to the end of this file, because without append mode file is, if I'm not wrong, is truncated and overwritten, and with append we go at the end of the file and we can append some data, but we want create, because we want to create that file that does not exist. Let's check out. Yeah, no such file. Moreover, we want to mode is. Do we need mode or no? Okay, let's make it mode user has write user has read permission and write permission. And let's back to our flags. We also want some flags like, I don't know, there is one important flag. Okay, write only because we want to. Okay, read and write. Oh, sorry. And create and read and write. Now let's try to compile our application. Okay, we have written a value and is unused variable. That's okay, because we can get char. And let's do one more thing. We want some speed, because we want to know the speed of the process we just run. So types no, yeah, we have speed of our application, and let's go to this. Okay, one more thing. Let's printf our file descriptor. It maybe we will try to make it in loop. Now let's check the speed. Okay. Okay. I see. Now it's okay. We have opened one file 10 times. Why not? But we can see that every open return another number. And in the fd info, let's take a look at the flags. We have flags 0100. Let's check out this. Maybe we can find out which flags has what values has each flag. Let's find this value in our Linux sources. I will look for some define or something like that. Yeah, oh, okay, it's in this file. Here, we used flag RGWR, and it has value 2, and it correspond with this value. This value is somewhere. Because it's some default value 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. No, it's not. 1, 2, 3, 4, 5, 6. Okay, there is some flag large file. I don't know, but it's default flag for open. Okay, so this is a basic example how to open a file and how to find out which files are used by the application. Okay, so that's all for first episode of procfs. In the next episode, we will look at the another file descriptors like sockets, iNotify, a pool, and pipes. But it will be in the next episode, because in this we have to learn about basics, and I also want to make my videos shorter than 1 hour. So these few steps is enough for today. Now I want you to invite to the Atmosphere conference. It's a conference for DevOps and system engineers. So if you are interested in these topics, you must be there. Okay, there is some quiz where you can win a ticket to a conference. This is the 6th edition of Atmosphere conference. Please write to this email in which these were previous editions of Atmosphere conference. I will draw a random email with a correct answer and a contact with this viewer to give him a ticket. That's all for now. Thanks.